So in this video I'm going to discuss code forces around 958 rated for division 2. So I will be solving first three problems of this problem set. So let's start with problem A, that is a split multiset. So in this question we are given a definition of multiset, in which multiset is a set in which there can be equal elements and which are sorted in ascending order. Okay. For example, 2 to 4 is a multiset. Now what they have given, you have a multiset S, and initially multiset contains only one positive number, that is n. Right. Now, here you can see the configuration of multiset. Additionally, we are also given a positive integer k. Right. In one operation, what we can do, we can select any positive integer u from S and remove one copy of u from S, and then insert no more than k positive integers into S, such that sum of all the inserted numbers is equal to u only, because the u is that number which you removed, right? And what is the minimum number of operation such that S contains n ones? So the question is very much simple. So let me discuss it here only. For example, you are given two numbers 5 and 2, which means your n is 5 and your k is 2. So greedily, what is the first operation? First operation would be like 4 comma 1, right? You will remove the 5 and you can only add k more numbers in the array, and that will be 4 comma 1, right? Next you will again perform the operation on 4. Now it will become 3 comma 1. Now again 3 comma 1 become 2 comma 1. Now again this 2 become 1 comma 1. So how, like this will also be carried out along with that. Okay, so how many number of operation did you perform on this 5 to get all ones? That is 1, 2, 3, and 4. Is it 4? Yes, it will be 4 only. Yes, it is 4. So now let me simulate this for, like, for 16 comma 4, right? Now for 16 comma 4, first you have 16 and then you have like how you can break it into parts. Select the 16, right? Break it into parts. Use 1 1 1, and last would be, I think, 13, right? Now break 13. How it will be broken? 1 1 1 and then 10, and similarly repeat the operation until all ones are there, right? So but just you have to do this operation only repetitively using a loop, because costs are very much low. So you can simply iterate a loop such that if this is your n and this is your k, right? And each and every iteration, what you are doing, you're subtracting k minus 1 from n, right? You are subtracting k minus 1 from n, because yes, here here my k is 4 and my n is 16. Now my n will become 13 because k minus 1 is 3, and you will subtract 3 from 16, that is 13. Now again it is 10. Now again it will be 7. Now again it will be 4. And at then it will be 1. At 1 you will stop. Right. So this is the thing which you have to do. Simply subtract n minus k minus 1 from n till the point your n is greater than or equal to 1. And count the number of operation in the order only. Right. So this is and that count will be your final answer. If I show you the code is also easy. Like um, okay, this is the only code, right? So first of all, I'm counting the number of, I think so, yes, this is the answer. So what I'm doing here, like if my n is 1, then answer is simply 0 and done. But else what I'm doing, I'm simply maintaining a variable name remaining, right? And this remaining variable is assigned to n, right? And also a count. This count is the number of operation. And what I'm doing, I'm simply subtracting k minus 1 from my remaining number, right? And increasing the count. And if at any point my remaining number is smaller than or equal to 1, then simply break and else, and simply break from the loop, and then print the count of that number of operation. So that's how you can solve problem A. So let's now discuss problem B, that is majority make majority. So let me discuss it here. So for example, in this question you will be given a binary string, right? You will be given a binary string, for example a binary string dash string which contain only 0 and 1, right? Also you are given a collective operation, right? What is that operation? For example, if I give you a array like this, like you can, and you will perform that operation on this array. And what is that operation? Simply count the number of ones and 0 in this array, right? Okay, counted. If my number of ones are greater than my number of 0, then replace this whole array by 1, right? But if my number of zeros are greater than or equal to 1, then simply replace this whole array by 0 only. Okay, which means if my number of ones are greater than zeros, then replace it by 1. If my zeros are greater than or equal to 1, then replace it by 0, right? So this is a operation which you can perform on any of the subarray of this array, right? For example, if I choose this subarray, then this subarray would become 0 only, right? Okay, but if I choose this subarray, then this whole subarray would become 1 only, right? So this is the operation defined to you. Now what question is asking you to do, simply tell him that whether at the end of at the end of any finite series of operation, will you get a single one as your final array, right? If it is possible, print yes, else print no. So how you can solve this problem? So the goal of the problem is to simply decrease the number of zeros, right? Is it correct or not? Yes, it is correct. So what you will do, simply you will combine all of the zero. Let me so the goal of the problem is to simply decrease the number of zeros, because you want one at the end. So first of all, you will try to decrease all of the zeros. So simply at any place, if you find the number of zeros in contiguous manner, simply replace all of the zeros with a single zero, right? Similarly, you can replace these three zeros with a single zero, right? After that, write the array again, right? Okay, writing the array again: 1 0 1 1 1 0 1. Now the answer is simple. If a number of ones are greater than number of zeros, then answer is yes, else answer is no. So that is the thing which you have to do in this question. But why it is working? So the main goal is like that. You want one at the end, right? So you will always try to remove the zeros, right? And how you can remove the zero? Simply the first part is simply that if they are collectively contiguous zeros, simply replace all of that zeros with single zero, right? Because if you perform operation on this on this subarray, the operation result would be single zero only. So I am replacing these three zeros with single zero, right? Okay, I have replaced it here. Okay, great. I have replaced. Okay, I have replaced it here. Okay, great. And I have replaced it here. Okay, great. Now what you can see, if after this operation you will after this operation you will always apply operation on the whole array, right? Okay, by applying the operation whole array, what is the condition to get a single one? If your number of ones are greater than number of zeros, then answer is yes, else answer is no. So that is the thing which you have to check after this operation. First, simply let me repeat again. Make collectively collect all of the zeros to one, right? If they're continuous zeros, replace all of that zeros with a single zero and write it here, right? And at the end, check if a number of ones are greater than number of zeros, then print yes, else print no. So that is the thing which you have to do in this problem number B. So let's now discuss the problem number C. Let me show the code also. So this is the code. Simply like replace all of the ones. Like I am simply maintaining two variables, count of ones and count of zeros, right? If my current number is 1, then simply increase count of 1. Else, at the position till my number of zeros are there, simply increase the counter and make only one count and add only one count for that zero. If your number of count of 1 are greater than a count of zeros, then print yes, else print no. Okay, so this is the simple problem. So let's now discuss problem number C, that is increasing sequence with fixed OR. So in this question you are given a integer n and you have to find the longest sequence of positive integers a such that a1, a2 and ak, the size of that array is k, which satisfy the following condition. And what are the conditions? The condition are like that your all of your numbers should be smaller than or equal to n. Okay, great. The a should be in increasing order. Okay, great. And the OR of the adjacent number should be equal to n, right? Okay, so hope so problem statement is clear to you. So let's now discuss the what is the major pattern in this problem, right? So let me discuss this test case 14. Okay, so let now debug the 14th test case. So what is the binary representation of 14? That is, I think so, 8 plus 2 plus 4. I think so, 8 plus 2 plus 4, and it will be represented as 0 1 1 and 1, right? Okay, great. Now what are the corresponding numbers with respect to 14? These are 4. What is the corresponding array of size k? I can also say that. So first number is 4. Okay, 4, it will be 0 uh, 0 0 0. Okay, great. Now next number is 10. Okay, great. 10, what is the representation of 10? That is 8 plus 2. Okay, 8 plus 2. Now next number is 12. What is 12? 8 plus 4, 1, 1, 0, 0. Okay. Now last number is 14 itself. That is 1, 1, 1 and 0. Okay, great. So let me remove this. So this is your final array. Like this is the final bit representation of all the numbers. Like this is, let me repeat it again. That is 4. This is 10. I think so. This was 12. This was 12. And this is 14. Right. So this is the thing which you have to output. Right. And what is the binary representation of 14? Let me write it here also. 1110. Okay, great. So let how we can get the because you know one thing, the OR of this and this is 14. Okay, OR of this and this is 14, and OR of this and this is 14, and this whole array is in increasing order. So this is the only condition which we have to satisfy. Okay, great. Now but like there's a very much big or good pattern in this whole problem statement. But what is that pattern? Let me tell you. mm, okay, great. So if we look carefully like that, so the what is the OR operation? What is the OR operation? OR operation is simply operation if one of your bit is 1, then the resulting bit would be 1 only, right? And if you want all of your numbers to be resulting in this sequence, then you must like if you're considering two numbers, number 1 and number 2, you have two choices, either to make this as 1 or this as 1. You have to make one of them as 1, right? So let me make this as 1. Now at this position you have again two choices, make this one or make this one. You can't make both of them zeros, but you can make both of them 1, right? Okay, great. Now at this question, at this level, I will try to make this as 1 and this as 0, and this will be 0 and 0. So this is property of 4, that if your any of the number is 1, the resulting would be 1, but if none of them is 1, the resulting will be 0. So which proves to us like that current bit is set if your current bit is set in your n, right, then in adjacent numbers one of the numbers should be having set bit on that position, right? You can see, consider like this. So if in this position all of the bits are set in this also and this in this also, right? So hope so this is clear to you. But how to generate these numbers? So there's a very much good pattern in this question. But what is that pattern? So let me write it again. Okay, so if this is my origin number 1, 1, 1 and 0, right? So let's forget the zeros part. I will only consider the set bits, right? If these are the set bits, I can only play with them because 0 will be 0 at the end. I can only play with these three set bits only. So, okay. So I will tell you the pattern of this problem. So write it all once, first of all. Okay. But how many times? Number of set bits plus 1 times. The number of set bits are 3. So write it 4 times. Okay, writing it 4 times. Now what is the pattern? Simply remove adjacent zeros. 0, 0, 0. Make write 0 here. 0, 0, 0. Now you will notice one thing, that what is this? What is this? Like this is 1, this is 2, this is 4 and this is 8. This is 1. What is this? This is 6. Okay, great. What is this? This is 10. Okay, nice. This is 12. Nice. What is this? This is 14. Your answer is in increasing order, right? And you can consider all of the adjacent ORs. The resulting would be 14 only in any of these cases, right? So this is the only pattern in this question. Like, let me now debug one more case. We will take 23. Okay, so it is 23. Now what is binary representation of 13? That is 16 plus 4 plus 2 plus 1. So it will be something like 1, 1, 1, 0 and 1. Okay, so this is 23. Now what I have to tell you, only consider set bits. Only consider set bits. So there are 4 set bits, right? There are 4 set bits. So what is answer? Answer would be fine 5, because what I have tell you in the previous example, like number of set bits plus 1, that many number of numbers you will be generating. Okay, so the answer is 5 in this case. How is 5? Number of set bits plus 1. But how to get the answer? But how to get the actual numbers? Okay, now consider writing these numbers only. First of all, forget the number, forget that indexes which are 0, which are not set, right? Only write let me change the color. Only write that numbers which are set in the original number, right? And how many times? 5 times. What is the 5? Number of set bits plus 1. Okay, let me repeat it again. How many times we have to write it? Number of set bits plus 1. Okay, that is 5. Okay, great. Now what you will do, you will simply add adjacent zeros. Okay, diagonally zeros. How? Let me tell you why. Remove this, remove this, remove this, remove this. Now what is right? What you will write? Write. Let me change the color. Write 0 here. Write 0 here. Write 0 here, and write 0 here. Right. So this is the only pattern in this question. So what is this number? This number is okay. What is this number? This number is 6 plus 7. Okay, great. This is 16, 17, 18, 19. Okay, 19. Next number is what? 19 or 16 plus 18. 18. Why they are both 18, 18? Okay, 21. Okay, 21. And what is this number? This number is 22 and this number is 23. Okay, now you will notice again this is increasing order, and all of this, any of this adjacent pair is simply, what is this? It is simply 23. Okay, so this is the only hack in this problem which you can solve this. So let me take another example, the last example which I am taking. So for example, you have a number whose binary represent whose binary representation is this, right? I'm not considering the number itself, but only taking its binary representation. So how many set bits are there? Total 1 2 3 4 5 6 7. So total 7 set bits are there. So what would be the answer in this case? Which means total number of the total size of array of that k size would be 8. Okay, that is number of set bits plus 1. Okay, great. Now write all of the numbers, like I will write here only. So 1 1, how many times? Number of set bits plus 1 times. Okay, number of set bits plus 1 times, that is 8 times. Okay, you can skip the part. I am writing all of the numbers 8 times only. How many times? 1 2 3 4 5 6 7, last time 8. Okay, so what I will do next, I will remove all of the diagonal zeros. Okay, but how? That is the question. Simply choose the first zero. Okay, but where is the eraser? Remove this, remove this, remove this, remove this. What is the next? I think this only. Remove this, and remove this. What you will write? You will write 0 here. 0, 0, 0, 0 here, 0 here, 0 here, and 0 here. It is 0? Yes, 0 here. Yes. So write the binary, write the final answer, binary, write the numerical, I think so, decimal number, write the decimal, 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 and this is your all of the final answer of your k size, and the size of the array would be 8. So that's how you can solve the answer. But don't forget to add these zeros, right? Because these are the also part. You have to handle this case explicitly, like don't forget to add the zeros in your final computation while you are computing this number, right? Okay, so that is the only thing which we have to discuss in the problem C. But there is also one catch. Like you can solve this problem. Let me tell you what is that catch. What is that catch? You can try it with yourself also. So what I am doing in this question only, like if this is my, like if this is my final one, let me take an example. Like if this is my binary representation, right? Okay, let me reduce the number of ones. Like if this is my binary representation, what I'm doing, I'm simply writing it 4 times first of all, right? Yes, writing it 4 times. Okay, great. Why 4? Because number of set bits are 3, and answer would be 3 plus 1 4, right? So that is the reason I'm repeating it again and again. So what you will do, what I'm doing here is like that. I'm just removing the one of the ith bit ith ith 2 from let me tell you what I'm doing. First of all, removing the 0, removing and writing 0 here. So what is writing 0 here means? What the writing 0 here means? If this is my n, if this is my original n, right? If this is my original n, remove that bit which is first of all set in your n. If this is your first set bit in your, if this is your first set bit in your n, remove that part from your n. Okay, what let me write it. What is the number? That is 2 1 1 2 4 and 8. And what is the final number? That is 12 plus 1, that is 13. Okay, so your first number, what is your first number? That is the first bit. Remove the first bit, 12. Okay, great. Remove the second bit which is set. The second bit which is set is this bit. By removing this bit, that is 4. Simply 13 minus 4, what is it? It is 9. Okay, great. Hope you are understanding this part. I'm just removing the set bits because adding zeros in the adjacent manner is this only. Like, if I uh, take my turn from the last, taking turn from the last is just removing the first set bit, that is 1. Removing 1 is 12. Now the second set bit is at 4th position, at this position, and at this position this is contributing 4 to my n. So by subtracting 4 you will get 9. Okay, great. And add then, subtracting 8 from your n, you will get 5. Okay, great. So, and what is the last number? That is itself 13 only. So this is the also trick which you can, in which you can solve this problem. So this is the explanation of all these three problems or this problem set. So if you like the video, please don't forget to subscribe my channel, and please share the video with your CP mates, and please do like, share, comment and subscribe, and don't forget to follow me on Instagram and connect me on LinkedIn. Okay, great. Stay tuned for the next one. Thank you.